I would try to go as fast as possible, starting from well, I skip the table of contents. Okay, starting from this was one thing which was not mentioned today. You may know about the controversial day. This is basically the day when we consume more than the plant can produce, and this year is around May. This is an average because it's very small, but for instance, if you pick single states like United States, we are mid of March. Italy, we are not so better, we are May again. But this basically means that we produce too much. So looking at also what Professor Coppola was saying, that maybe we don't have big alternatives to Portland cement. So what we can do, we can cut by half, okay, very simply. But see that nobody wants to do that, or at least nobody wants to do that in short time. So in the meanwhile, we have to do something. Of course, there is a problem that some countries can produce more, but they also spend more. And as was said at least a couple of times today, the building sector is under attack, right? Because it's responsible of a lot of global energy consumption and also the greenhouse effect emissions. So what is one of the strategies that is not the solution, right? One of the possible strategies is, for instance, looking at timber hybridization with concrete. There is a lot to do here because we need to investigate which are the hybridization techniques, which means not only the single structure element, is not the point, but is the construction system. We look a little bit at construction system today. We need to collect real case study. We'll see we don't have so many, and we have to compare with traditional solution, otherwise it doesn't work. So very quickly, it was also mentioned this circle by Professor Riva. So we know which are the stages of life cycle assessment. We typically tend to consider stage D, which is beyond system boundary, as optional, but we really could not do that anymore because it's quite fundamental. If you look to timber, for instance, it's quite interesting to see this because it is what one of the things which could make it work, in the sense that if you reuse, then you go negative in terms of GWP. If you recycle, you go negative. If you go to incineration, not so bad. If you go to landfill, no way. I mean, we are back. So this is a scenario, let's put it that, which we cannot consider under any circumstances. Let's look at the big solution. So this is a European seismic hazard map where there are some buildings superimposed. So here you can see this legend. Basically, the green one are with reinforced concrete core, while the other ones are with timber stability system. It's curious because when I showed this in Europe, some colleagues look very well, because if you look where you have spruce, it's not where you have seismic hazard. So nature is giving a call in Europe, right? And in fact, the highest buildings which are with stability system in timber are all located in parts which are not of significant seismic hazard. It's a little bit different here in North America, because actually one of the fewest places where you have high seismic hazard and a lot of timber is basically here, from California going up to British Columbia. And in fact, if you look here, when we start to go a little bit up, I mean, higher than 4 stories, there is no way, basically. So the stability system is a reinforced concrete. There is actually, well, this is few blocks down here, and this is in timber, but we cannot go higher than 4 or 5 stories. And when you have high-rise building, now this should be the highest timber building in the world, is in Wisconsin, where I would not say it's really seismic prone region, right? So how we can approach then to that? So this is from a previous work which we presented at a conference relatively recently, when you can see that this is a summation of all the contribution from the different stages for buildings which are comparable. It's quite hard to find the literature, this information for buildings which are more or less the same size, let's put it like that. These are some buildings in reinforced concrete, these are mass timber, and these are with CLT. You see that for some of them, when you consider consider stage D, so you can go, let's say, a little bit negative. But as was recalled by Professor Ferrari in the beginning of this session, recalling Professor Scrivenes, we cannot replant India every year. So we need to do something like that. So the case study yes. So we try to apply this to a real case in Milan. So we consider this building, which is quite medium size, so 64 meters by one side and 15 one other. It's 8 stories, so it's not so small. It's mid-rise, and it's in Milan, which is low moderate. So this is a plan of the original solution reinforced concrete. Well, the 2 cores, a little bit of eccentricity, but not that much. Everything works. This is the solution when you want to replace the RC with CLT. The number is consistent, okay, right? But this was done preserving the architectural layout. It has to be said that in this type of solution, you don't have the same flexibility for future use because you are a little bit more obliged by the fact that your CLT was here. Oh, one point here, in this case, the columns are in steel. It's absolutely not convenient to talk about timber here because when you start to go up, here the size of the timber column would be 80 centimeters, but nobody would use would lose all that room. So you go with 24 centimeters steel profile, end of the story. We'll see later that this has really no impact on the on, um, on our, let's say, environmental indicator. So what we consider is reinforced concrete solution, which is classical. With this hybrid, well, hybrid, we mean that steel columns and beam are given for granted, and we use CLT walls and floor panel. And another solution when we are replacing the stability system, so from CLT walls to reinforced concrete wall. Very quickly, this is just how we evaluated the impact indicator. So automatically through a software and looking at EPD data for the panel. Which are the solution? No worries, it's quite easy. So we have the reinforced concrete classical when you recycle nothing. Then you have the hybrid when you reuse everything, the hybrid when you recycle everything, then the hybrid when you go to landfill, and something which looks a little bit more reasonable in the sense that it's not really thinkable of reusing everything, for example, from the panel because you have to make some adaptation. So this is a solution when we reuse the majority, but the rest goes to incineration. And to make the final comparison, we are considering one final case when we do not replant. So we don't have India available, we do not replant, and we see which is the effect. Because at the moment, the really the item which is really has lots of impact when you consider LCA for timber building is the assumption that you have something stored at the beginning here because you have a replantation. So which are the other variables that we consider? So one thing, typically in this comparison we neglect stage B, which is the use, but this is the phase which is more responsible for the emission. So in a low energy efficiency, this is responsible for 80%. So we are fighting against on the structure, but which really may not have impact. And so we consider also another scenario where we have a high energy efficiency, so where the stage B is only 60%, but we see which is the impact. So one, I cannot neglect this because in mid-rise and high timber building, what we is faced as a very tremendous problem today is the connection to foundation. The forces which are developed are such that traditional solutions do not work so much. So here, maybe it's green, not very visible, but we have an incredible number of hold downs, and this is a classical CLT panel. Just want to mention one thing, that the total volume of connection here is quite negligible, both in terms of volume and on weight with respect to total load. So it doesn't really play a role. Which can be interesting results. Okay, so maybe I have some time, so I will dedicate some more seconds here. So in terms of material volumes, this is, I think, what is relevant. So foundation are always in concrete, no way, right? So they are always there. Columns and beam do not really matter, right? So here, if you go to steel, I mean, it's not worth to insist on something different than the system which provides the faster reaction sequence. Where you can work a little bit, well, on slabs, for instance, right? Because in slabs, in the end, you have basically almost the half. So if you want to go to a solution which maybe can be a mix, it can be a good compromise in terms of erection, speed, usage of floor, and to balance a little bit the emissions, let's say, and use of resources, it can be very efficient to work on slabs, which is what is done, for instance, by this hybrid solution. In this analysis, what comes out? So these bars are just A to C and including D. So to recap, this is with the final, the beyond life, okay? So, and this is without. This is the classical reinforced concrete, so what is currently under attack, we could say, this other side. Then you start to see if you use timber with full recycling and you go below, so full use, full recycling. But you start to see that if you go to incineration or you go to a partial use, the benefit is not that big. And what is relevant is this, I think. If you do not replant, this is the result, and this is the traditional RC structure. So, give some thought, right? So again, if you don't have India and over here, maybe this is not the more efficient. So this is just to say that again, this is not the solution, but probably we need a mix of that. Finally, before the conclusion, I think I'm on time. Just to take a look to the fact that this impact is we have an impact if we consider a stage B, which impacts for 80% of emission, right? But we really need also much more energy efficient building to see that we have a difference among the different strategies. Because otherwise, whatever the strategy, if your building is not efficient, which is here, yeah, there's some difference, but they are not tremendous. In conclusion, we need an accurate design of building efficiency is crucial, as we said. Deeper capability to bring down the CO2 emission lies in a well-thought management of phase D, and we can achieve sustainability through, say, if we consider this as a part of a microscopic system. Of course, we had to consider cost, okay, on the top of this, because now it is this analysis is neglected. And last 2 points. It is possible to take advantage of negative CO2 emission in case the panels are not reused or recycled. And in this case, the choice of hybrid frame resulted was suitable. And let's look at this last graph, which reports let's call it that, the emissions per cubic meter. This is CLT with reuse. Looks fantastic. This is CLT with no replanting, right? So what happens if we cannot do that? And this is our concrete. So this is our traditional approach. This is if you count a little bit better stage C, but if you try to recycle a little bit, this is where we end up. And for slabs, for instance, if you consider that a little bit optimized slabs of concrete as half of the volumes of timber, so you have a ratio of 2 here. So these 2 numbers in the end are not that far. So just to give the idea that again there is no the solution, there is no one single strategy, and hybridization looks very promising to us, but there are many things to consider and to be a little bit holistic, as we used to say. Thank you very much, and
thank you.